This is the last lesson of chapter 3, and we're going to go ahead and you can pause the video, work through factoring. Now this says to factor out the GCF first, right? So that means I want you to factor out the GCF and then go ahead and factor what is left. So you could still do CAB to factor that, or you can do the box method in reverse, or you can try to do it by grouping. So go ahead and factor out the GCF first, and then go ahead and use CAB with the remaining factors. All right, now I'm going to do it. Okay, so we're factoring this, so looking for a look at the number and variable to see if we can factor anything else. We can see that we can factor out a 4 from all of these. So we take out a 4, that means we're dividing by 4, right? Factoring is division, so we divide all of these by 4. So that 4 comes on the outside. You have to leave that 4 on the outside, and we get left with a x squared minus 3x and then minus 4. You could always ask yourself, what times 4 times what is 4x squared? What times 4 is negative 12x, to fill in that. Okay, now we can go ahead and use CAB to do this. So now our a is 1. That's how many x squareds I have, or the coefficient in front of the x squared. B is the coefficient in front of the x, and C is our constant, the one without the coefficient. Okay, then we multiply our C times our A. That's CA. And then our B is negative 3. And since these are both negative, we could look at that chart and say, since this is negative, that means I'm going to subtract to get to negative 3. But let's not worry about that negative. What this negative in here means that just the bigger number of these two are going to be negative, okay? So what times what is 4, and what minus what is 3? So that's 4 and 1. And since this is negative, that just means the bigger number here is going to be negative. So that means negative 4 and positive 1. So x plus 1 and x minus 4. Don't forget to divide by your a. My a here is 1, which divided by a is not going to change anything. But I need to remember also to put out that 4 from the beginning that we factored out first. So here's our answer, number 1. Okay, so that's factored completely there. Now go ahead and do number 2. If you haven't started number 2, go ahead and pause the video and try number 2, because I'm about to do it. Right, look, what can I take out? Seems like a 6, right? So as 6 times what is 6x squared? That'd be a x squared. 6 times what is a 24x? That'd be a positive 4x. And then what 6 times what is negative 72? That'd be negative 12. Now we go ahead and use CAB. Our CA would be negative 12. Our B is our coefficient in front of x, which is 4, a positive 4. Again, since this CA is negative, we're going to be subtracting to get to 4. And since this 4 is positive, or since our B is positive, that means the bigger number is going to be positive. So what times what is 12, and what subtracts to 4? So we have 3 and 4, we have 6 and 2, we have 12 and 1. So that'd be 6 and 2. And 6 minus 2 is 4. So we have, excuse me. So we have 6 and 2, a positive 6. So x plus 6. Bring down the 6 that from right here. Bring that out front. And then we have x minus 2. Okay, and there it is. That's one done. That's number 2. Okay, last one. What can we take out of this? There is no number, so I guess there's no GCF, right? Go ahead and pause the video if you haven't started number 3. So there is no variable, or there's no number that we can take out of all 3 of those except for 1, and that's not going to change anything. But look at the variable. Don't they have all x's? So can we factor out an x? So take out an x. So x times what is x cubed? That'd be an x squared. X times what is a negative 8x squared? That'd be a negative 8 and an x. And then x times what is 16x? That'd be positive 16. Now we can go ahead and factor this, use CAB. This time CA is positive 16, so that means we're going to be adding to get to our b. So we're going to go ahead and be adding to get to our b, which is negative 8. So even though that's a negative 8, we're still going to be adding to get to 8. But since that b is negative, that means both our numbers are going to be negative. So what times what is 16, but adds to 8. So that's 4 and 4, right? 4 times 4 is 16, and 4 plus 4 is 8. But since this is negative, that just means these are both going to be negative. So x minus 4, bring down the x in front, and there's our answer. You can look again just in case. You would always want to kind of look at these. We want to divide by our a, which is 1, which is not going to change anything, right? So that's fine. And then the other thing you want to look, see if you can factor anymore. Can I factor anything out of this binomial? Can I factor anything out of this binomial? Just in case if you didn't factor out the GCF to begin with. All right, so here is a summary of how to factor binomials, or polynomials, sorry. So always look for that GCF. That's the first thing. Always look for the GCF in both number and in variables. Okay. Once you have that, if you have a polynomial with 2 terms or 3 terms, look for a difference of 2 squares, a perfect square trinomial, or a pair of binomial factors, right? That just means you could still do CAB, right? If you're really good at CAB, you can still do CAB, but difference of 2 squares is really fast, right? Something like this, 4x squared minus 9. So here I could just, what times itself is 4? That's 2 and 2. What times itself is x squared? That's x and x. And what times itself is 9? That's 3 and 3. But one's negative, one's positive. Look how fast that was to do a difference of 2 squares. So we always kind of look for those easy ones to do first, so then we don't have to do CAB. Here we could still do CAB. Our b would just be 0, right? Because we're missing the coefficient of our just plain x, right? There's no plain x in there, so 0 would be our b. Okay, if we have 4 or more, then we want to do it by grouping, and that's what you're going to learn today, as to how to factor by grouping. And then we always want to check to make sure we have no common factors other than 1. So how you can do that, just like I kind of did at the last warm-up, I looked at those binomials and seeing if I can factor anything else out. Okay, so these are the steps. You want to write them down, and then every time you're asked to factor, you want to kind of follow these steps. Alright, so let's go factor this cubic, and we can always look for the GCF. So we look at all 3 of them, look for the GCF. Since that has a 3, that means we're not going to have a number, right? And there is no n in all of them. So now we're going to do, since there's 4 more, we're going to do by grouping. Remember, this is how we draw a line. We look at both sides of this, of the left side. We factor out the GCF, so that would be a 3. And then 3 times what is n cubed? Or 3n cubed, that'd be an n cubed. 3 times what is a negative 12n squared? Well, that would be a negative 4n squared. Now I can look at variable if you didn't, right? Don't they both have n? Now what's the smallest exponent? That's 2. So we're going to factor out an n squared. So a 3n squared total is what's going to come out. N squared, how do I get to an n cubed? Well, I need an n. I have the minus 4 in there. How do I go from an n squared to an n squared? I don't need to add anything. So there's factoring out the whole GCF there in green. Now let's just factor out the whole GCF on this one. You should know from practice, if you've worked on these before, that since I have this binomial, that means on the right side here of this line, I should have that same binomial, n minus 4. So now you can just ask yourself, what times n is 2n? Well, that should be positive 2, right? And then you can check positive 2 times negative 4 is a negative 8. So you're good. All right, now we're going to factor what is the same on this left side and this right side. They should always share this binomial in parentheses, so you're going to factor that out. Just like you divided by 3, you factored 3 out of here, right? We're going to factor out an n minus 4, and it's going to come out, so we get n minus 4. And then since that comes out, that's gone, and what's left is a 3n squared plus 2. Now here's where you want to check, just kind of like the last one, check to see if there's any more that you can factor out. So we look at this, can I factor anything out of there? Is there a common factor? What about this one? Nope, so that's it. So I am done. Alright, you go ahead and try this one. Look for the GCF in all of them first. Okay, if you can't find a GCF, then you're going to go ahead and factor the left side and the right side, and then when you factor those out, what's left in parentheses and those binomials should be the same on the left and the right, and then you can factor that out. Okay, so go ahead and pause the video and try it yourself. Alright, so I'm going to look for the GCF here. So a 2 can come out, right? And what about a t? Any t's? Look at the smallest exponent, it's a t squared, so a t squared is going to come out. So then you can ask yourself, 2t squared times what is 8t cubed? Well, 2 times 4 is 8. T squared, I need t cubed, so I need another t. Now I can look at 14. 2t squared times what is positive 14? Well, that's positive 7, and it's a t squared and a t squared, so I don't need any more t's, right? So that means that this right side parenthesis should be 4t plus 7. If not, I might have to rearrange those 4 in a different way so that I can get, when I factor out, it should be the same. Now you can ask yourself, what times 4t is a 20t? Well, that's 5, and it doesn't need a t, right? It's a positive 5, so make sure you put a plus 5 there. If it's a negative, make sure you put a negative 5. And then you can check, is 5 times 7 35? Yep, so you're good. Now we can factor out what's the same on this side and this side. That is 4t plus 7. And then when you take that out, what's left? 2t squared plus 5. Doesn't matter which order these parentheses go in. Okay, go ahead and try this one by yourself as well. Look to factor the GCF first, and then draw your line. Even after you factor out the GCF, you could, if you factor out a GCF, you could just put that in parentheses and then do it again. You'd still have 4 terms here. And then you can draw your line and go ahead and break it down from there. Okay, pause the video, because I'm about to do it. So I look for the GCF in all 4 first, which there is something, right? There is a 4, right? A 4 is in all those numbers. And also there's a q in all those numbers. What's the smallest exponent? Is a 1 here. So a 4q is going to come out. So 4 times what is 4? That's 1. Q times q to get to q to the 4th, that would be q3. 4 to negative 8, that's a negative 2. Q to q3, I need a q squared. And then on this side, 4 times what is 12? That's a 3, a positive 3. So you can put a plus sign there. And a q to q squared, I still need a q. And this one, 4 to negative 24 is a negative 6. A q and a q, so I don't need any more q's. Right? Now I can draw my line, which I already kind of have it there, and I can look now, what can I factor out? Just the left side here and just the right side. So the left side, we can see we both have q's. What's the smallest exponent? That's a squared. So we can leave out this 4q on the outside here. Okay. Brackets are just grouping, right? So those brackets there are just like parentheses. So I can factor out a q squared, and then what's left? Q squared to q3, I need a q. A 1, so there's a 1 in front of here. 1 times what is negative 2? A negative 2. And a q squared, I already have a q squared, right? In this one, what can I take out? You should have left, right? You should have a q minus 2 left. So you can ask yourself, what times q is 3q? That means a positive 3. Make sure you put the plus sign. And then check. 3 times negative 2 is negative 6. So you're good. So that 4q from the beginning is out front. Now, what can you take out of this side and this side? The same. That is a q minus 2. And then what's left? We take those out. A q squared plus 3. Now again, last step is to check. Can I factor anything out of that? Can I factor anything out of that? Nope. So there, I'm done. If you didn't factor out the GCF from the beginning, what would happen is one of these binomials would be, you could factor something out of them, and it would be a 4q that you could continue to factor out. Okay, here's another one. Go ahead and pause the video and try this. Again, you're probably going to factor out a GCF first, and then draw your line, and then factor out of something on this side, and factor something out of this side. And the parentheses should be the same, and then factor out that parenthesis. Okay, go ahead and pause. I'm going to start. So I look at all 4 of these. I see that 6, 9, 12, and 18 all have a 3 in it. And they all have an h, right? And what's the smallest exponent? Would be 1 there, so I'm going to factor out a 3h. And say I didn't factor that out, okay? And say, oh, I didn't notice anything. So then I just look at this side and say, what can I take out of there? A 3. And then what about the h's? They both have h. What's the smallest exponent? 3, so h cubed. And 3 times what is 6? That's 2. And h3, I need to get to h4, so I need another h. And now 3 times what is 9? That's a positive 3. And an h3 and h3, so I don't need any more h's, right? Then this side, that should be the same, right? A 2h plus 3. So what times 2? What times 2 is 12? That'd be 6. And what times h is h squared? I need another h, right? So it should be a positive 6h there. Now they're the same. I can factor that out because 2h plus 3 is the same on both of those. What's left? A 3h3 and a positive 6h. Okay, now I can look at these and notice, hey, on this binomial, I look at both binomials, this first one, I can factor out a 3. So I factor out a 3. And also, look, they both have h's, so I can factor out an h. And the smallest exponent was 1, so I can factor out a 3h. So I'm left with 3 times what is 3? That's 1, so I don't need to put anything there. H, how many more h's do I need to get to cubed? I need a squared. And 3 times what is 6? That's a positive 2. And h is already there, and I have an h, so I don't need to add any more h's. So just in case you forget to factor out, you can always check it, and then you can factor out at the end. So that'd be your final answer. And again, you could check it. I don't have any more h's, don't have any more h's, don't have any numbers that I can factor out besides 1. Okay, so you can read this problem and be confused about what you're asked to do here, but you're just asked to write the dimensions of this volume of a rectangular prism, right? Or maybe that V doesn't stand for volume. But it says use factoring. So basically, aren't you just going to factor this? So always look for the GCF first. And the dimensions would just be the side, right? The sides of this. And since it's volume, I believe that V is standing for volume, you're going to have 3 factors, right? Volume is length times width times height. So you're finding the length, the width, and the height. What that means is you're probably just going to have 3 sets of parentheses, right? Or something out in front, the GCF, followed by 2 sets of parentheses. All right, so GCF. Something like that, because you have length, width, and height. So all you're doing is just factoring this. So look at the GCF. What's the same in all these? 6, 9, and 19. Well, 19, I can't take anything out of there besides 1 and 19. So look at the variable. Don't they all have x in it? So let's factor out an x. We get left with 6x what? X times what gets me to x cubed? Wouldn't that be an x squared? X times what is x squared? Don't I need another x? And then x times what is x? Just 1, right? So I don't need any more x's on that last part because that x right here takes care of this x. Okay, now we can go ahead and do cab now, right? You could do grouping, but there's not 4, right? So you would have to separate this 19x into 2 numbers. You'd have to be like like 14x and plus 5x, so then it would be a group, right? But you might have to mix those up and guess and check how to divide those. But cab, I think, is the best way. So you could do your c times your a, so 6 times 15. So sometimes if I don't know what 6 times 15 is, which can't think off the top of my head right now, but I mean, sure, it's 90. But so CA, I know it's going to be 6 and 15, right? There's one combination. And then my B is positive, right? So this is positive, and so is this. So I can ask myself, what times what is whatever 6 times 15 is, and then it also has to add, because this is positive, it has to add up to 19, right? And since B is positive, they're just going to both be positive. So I have 6 and 15. I know those don't add up to 19, but can I break this down to 2 and 3? And then 2 times 15 would be 30, and then I have that 3, so 3 and 30. Do those add up to 15? Or to 19, sorry. And then, so I can't do that. How about, mix it up some more, how about 45 and 2? make sure I have this right. 45 and 2. That doesn't add up to 19. So is there anything that's going to work here? Let's see. How about smaller numbers? How about 9 and 10? Right? Because I could break this 15 down to 3 and 5, and then 3 and 3 would be 9, and 2 and 5 would be 10. So 9 and 10, and 9 plus 10, hey, that does equal 90. So we have the GCF on the outside, and then we have an x plus 9, and an x plus 10. Remember, we are not done because we got to divide by our a, 6. So we always reduce the fractions as much as we can, and then we want to check. So this is reduced down both by 3. 9 divided by 3 is 2, or is 3, sorry. And 6 divided by 3 is 2. There is my 2. 6 and 10, 2 goes into it. 10 divided by 2 is 5, and 6 divided by 2 is 3. Now, since we reduced those all the way, now we can take our denominators and move them in front. So 2x plus 3. Take that denominator, move it in front. You get 3x plus 5. And now we do a little bit of check. You can multiply this all the way out to make sure you get the same thing. But sometimes I'm lazy and I just multiply first times first and check and see if it's the first thing. So 2 times 3 is 6, so we're good there. And x times x is x squared. So I think that will work all the way through. If not, you could FOIL this out, FOIL the two binomials, and see if you get this. And if you do, you know you have the correct answer, right? All these, you can figure out if you have the correct answer or not. So those are length, width, and height, or however they have it. Okay, go ahead and try this one on your own. Same thing, right? So factor out the GCF first, and then go ahead and use CAB to figure out what the length, the width, and the height is. Okay, go ahead and pause the video if you haven't done it yet, or because I'm about to start. Okay, so I look at all these three numbers. They're all even, right? So I know a 2 goes into all of them, and they all have an x, so I want to factor out an x as well. And then 2 times what is 60? That's 30. X times what is x cubed? That means I need an x squared. 2 times what is 17? Or sorry, gave the answer away. 34. That's 17. X to x squared needs another x. And 2 times what is 4? That's a positive 2. And it already has the x in it, so I don't need another x. Now I can go ahead and do CAB. C times a. That is a positive 60. Since it's positive, that means I'm going to be adding to my b, and my b is also positive, 17. So that means they're both going to be positive. So what times what is 60 but adds to 17? So 6 and 10 is 16. How about 12 and 5? Oh, that's 17, so 12 and 5. So I got the 2x on the outside, a positive 12, and a positive 5. Don't forget, divide by your a, which is 30. So divide by 30. Reduce these fractions. 12 and 30 both have a 6 in it. So we can reduce those by 6, so 2x. 12 divided by 6 is 2. 30 divided by 6 is 5. 5 and 30 both have a 5 in it. 5 divided by 5 is 1. 30 divided by 5 is 6. Now we can take those denominators, move them out front. So 5x plus 2 and a 6x plus 1. Now we can do a little check, right? 5x and 6x, is that 30x squared? Yes, it is. So we are all done.